It's going.
It's on the 0 now, it's touching by about 5. It's now compression. That finger indicator.
On the
0.
0, right.
Of the shoulder. Just look,
shoulder.
it's not too... it's not close to the lady, so just lift. Yeah, make a 0 of that.
Okay, so we go relative, X, Y, Z, 0. So they're all on 0, you see.
Okay.
Then we go up.
Move the table towards me.
Really? You don't want to go up in the Z?
Oh, well, I only flip off by 5 now, so not much.
Okay. Move the table towards you.
Now, go and touch this part here.
The crown wheel.
Crown will face.
Okay.
Go down and see what it is. Hang on, you've got the 2 bone. Up a pound more, 3,000. Right, make a note of that.
Okay, well that's 37.38. This is a stock BMW carrier out of the BMW diff. We're just doing some measurements here because they reckon that they want us to do it their way. We're just going to see if it is even a plausible way of doing it. What are you doing?
Alright, well now, oh fuck me, we'll have to set, well it doesn't matter, go up a touch.
Go up, Z positive.
Right, there enough. And come down now and touch that till it goes to the 0, right?
I'm coming down. You tell me when to stop.
You see the clock starting moving, keep coming. And a couple of mil or 3 mil to go yet. Now, getting close now. There you are, back to the 0.
You've gone back.
That's it. Make that the 0 on the dials. Yeah.
Okay, so we go Z 0. Right, so we're all 0.
Lift it up.
Okay. Coming up.
A bit more, and we're going to go to touch that shoulder, see?
Right.
Get the work to go near the indicator. Go along a little bit too, go along that way.
It's real difficult because I cannot see. You're standing right over it. And I'll come down. I'll get there.
There's a land there, there's been a cutout.
Yeah, I just want to get it near there so I can see.
Oh, we'll go to this one here.
That's what I'm doing.
Alright. Alright, that'll do you. Yeah,
Right.
only a couple down more. That's it. What's the difference between the two?
That is 36.53 and the other one was 37.38.
36.53.
So 36.53, look. 36.53 and the other one was 37.38. So they're the difference between the two.
That's 8. That's 0. That's 0.85 of a mil. Isn't it? 5, 13, 8. 0.85 of a mil, rate makes him a 32. It's about 33 thou, isn't it?
Right. So what about it?
Well, it needs packing up with a washer.
I see.
0.85.
So you need to make a washer. So you machine that off there, grind it, put holes in it, put it on there. It's going to have heaps of backlash.
33 thou we've got to make the washer.
So you need a 33 thou washer.
We've got some washers here. We made amount of...
Am I still filming all this?
well, we've got these washers here.
What do they say to do? Do they say to use a washer?
Oh, they reckon you should just leave a ridge there. You don't get the two
Yeah, that's a washer. This is for another BMW diff. But they should be supplying these in the box. Because not everybody can make stuff like this. We've got a whole workshop full of equipment to make pretty much anything. But just a normal person buying one of these would not be able to make that.
I reckon you should leave about 33 thou on and we'll have a shoulder. There you see.
Right. And why don't you want to do that?
I'm not going to do it. They reckon they do it. So what you got here? You got the that's a pitch. Well, the outside diameter of this. And if you left this ridge, you have a tap dial going into, there'd be a step, there'd be a 33 thou step when I machine that off. These washers, made these, it's only way you want to clean the whole lot up, you don't want a ridge. I'll get this off in a minute. So, this will be just a bit close to 33. We can grind this if we wanted to. I'll go and get a micrometer. 33 thou.
How come they make them 30? Why don't they just make them correct?
That's a good question.
Why go through all this, leaving a ridge on it and all this unnecessary stuff?
I can't get an answer out of them. This is 37.
This is all.
37. So about 3 thou up.
All this is pointless.
Correct.
Why don't just, when you said to them ages ago that they're the wrong offset by 33 thou, shouldn't they just be like, oh shit, we mucked up. Okay, we'll take a note of that and we'll start manufacturing them with the different offset. Yeah.
Now this one here, you've got the jigs there to hold this crown wheel. This one here is the 115. This is vernier.
Use the bloody one over there I bought. The good one.
Well, it's 115 this thing.
Mm-hmm.
That's right. 115 mil bore. 2, 4, 6, 8, 10. We made them 12 mil by 1.25, didn't we?
Yeah.
I don't know whether you you go off the pitch circle diameter on your programs, is you right?
Of course.
You do. Look, this vernier made
There's 3 different programs. There's big, medium, and small. PCDs.
this must be the 123 one.
Mm-hmm.
The 123, is it?
Yeah.
Alright, we'll pick that one out.
Okay.
I'll machine this off.
Yeah.
And by the time we clean that up, That'll be 3 thou. It would take that perfectly, wouldn't it?
Yeah.
You see? So I'll machine this off. You go and wipe the program.
So, here's the program for it. 135 PCD. I made that back in 2019. What's that? 19, 20, 21, 22. So 4 years ago I made this program. But anyway, this uses a tool 4, 10mm end mill, tool 5, which is 12mm by 1.25 pitch tap. Does the holes and taps. But look, if I go into this, to all my programs I've made over the years, let's open that up a bit. So we've got 2 columns. Now you come down, you've got BMW crown wheel, the 145 PCD. That's the big one. Then we've got the that's the medium one. Then we've got 153 PCD, which is the big one. And then we've got the 135 PCD, which is the one we're doing today. It's 135 PCD. And you see, this is the program. If I just grab that and show you all this. This is what the CNC machining center reads. See this part here? That's the tapping. That's to tap the holes. Once you work with this crap, you start realizing what it all is. But at the moment, whoever's watching this, you're probably just thinking it's just a bunch of numbers, mate. But it is a bunch of numbers, but it's a code, you know, G code. You see, you got M8, turn the coolant on. Z0, got, you know, your home. It grabs the tool 4, grabs the tool. M6 is the tool change. Changes to the tool 4, which in this case is a 10mm end mill. And it does the height offset and everything. The spindle speed is 400. And then it starts doing the hole. This section here is 1 hole. This is a counter bore. Feed rate is 15mm a minute. So that's 1 hole. Then it comes and does the next hole. Then it does the next hole. And so on. And that's how the machine works. Now, to put that program in here, you go like this. You push this button here, and you go read. See, there's no other programs in there. There's just a macro, which is always there. I can't get rid of that. So we go read. See, it's waiting. It's waiting for the program. We come over here, and we go up to this thing just there. Send to CNC machine. Click that, and you see, off goes the program. It's all going in. So off it goes. It's going into the CNC machining center, into its memory. And boom, done. We come over here, and there it is, you see? It's in there. So we come back to this, and we go, okay. Then we can close that and wait for him to come over with the crown wheel.
This is what they're suggesting you do. Leave that up about 33 thou, and then you wouldn't need to use this washer.
When you say they, you mean
the people that make this this quaife mob.
Okay.
This is a series 5, isn't it? These are the standard carriers busting half.
Right.
What's this? What's it called? A QDF13N?
That's what it says.
Right. Well, we measured it at 33 thou difference, didn't we?
Mm-hmm.
From that face on the standard carrier to the shoulder of the journal, and from there to there, this 33 thou has to be made up if added to that if you want to take to that face. Now, you wouldn't, anyone in their right mind wouldn't want to do it this way, because you've got an interrupted entry to the holes, haven't you? They're cutting into here.
I know, it's engineeringly wrong.
That's right. They make a fine product, but they always leave some bullshit idea behind. So I'll just piss that all off, and we'll just put this washer on there. Just grind about 3 thou into that, because this is about 3 thou over it. Was about 37, about 4 thou.
So they expect you to, instead of use this washer, they expect you to leave this ridge there.
That's right, leave that ridge there, and the holes are breaking into this area.
Unbelievable.
Because there's the true stud pattern, because we made these washers the last time we did one of these, remember?
I really just can't understand. You tell them that it's the wrong offset. Why don't you just go, okay, and then just make that thicker? Why?
I can't work it out.
Why do you have to go muck around with all this every time?
It's bullshit. They're mad.
It's like they don't want to admit, you know, that they've done something wrong. They just want to...
So that's going to break into over a shoulder, over a machine diameter, isn't it? Over this diameter here.
Yeah.
You're gonna have a hole. You've got to have a counter bore there anyway, but it'll be much cleaner just to go straight across.
Mm-hmm.
We've taken a witness mark on those two. We've counterbored this out so we can hold it in the lathe to rough all this shit off.
Mm.
That's the new datum area, because that was taken off from the original face down there.
Mm-hmm.
Before we started machining this off, so we wouldn't lose our datum.
Mm.
That's the way we've been doing it for years. But people just want to buy stuff that you can just do it the most practical way. Just take that all off, put it on here, and it'll be roughly right within 5 or 10 thou. None of this putting washers here. So anyone who suggests you do that, instead of cleaning it up right across here, would look up their mother's skirt. I'm telling you.
Yeah, it's very
So I'll put
strange.
that in the lathe, and with the ceramic tip, I'll just rough that off, and then I'll just grind it until a couple of thou into that. Slam that washer between them. You can do your counter boring, and it'll be all over. So go and quickly machine this shit off. Do it the most practical way.
So we make this washer to compensate for the mistake made in that. Because this, where that is there, it's 30 thou, almost a mil that way too much. It needs to be that way more. You need more material on it. So when you take these crown wheels off and grind it square, it goes on and has the correct amount of backlash. So you don't have to make a washer. Making washers like this takes time. So I don't know, why can't you just make that thicker? Why do you have to have this ridge thing on the crown wheel with holes half breaking out of the ridge? It's ridiculous. Rightio. So, we've got this fixture, you see, for these crown wheels. Instead of clocking up the bore with a dial indicator to find out the centre position and then clamping it with some bars, what we do is we make these fixtures. You see this round thing here? It's machined so it just fits in there. It fits in, and then you can put bolts on there and T-nuts underneath, do it up. And then we've got this tool here, you see? This is tool 10 I have it in. That shaft there fits in there perfectly, and then once you do that and then tighten it up, you're in the center position. So when you go into your offsets, you can put in your offsets, you see? Go position, there's the offsets, put them in. So it's super quick. See, we got, that's for the big BMW, and then that's for the medium sized BMW. And then this is for the small BMW. Works pretty good. Anyway, so now what I need to do is go program. Tool 4 is a 10mm end mill. So we go manual data input. We go tool 4 ender block insert. Get out of that a bit. Ender block insert M6 ender block insert. And you see that? nice long 10mm end mill that's coated. See, it's coated. Very hard, that. So what we do is we go to rapid position down. We're going to touch this end mill on the top of the job so the machine knows where to go. So let's get a piece of paper. Put the piece of paper here. I'm doing this all one-handed, so it's going to be a bit tricky. So I just got to feed it down. Let me see if I can put this phone somewhere. Let's sit here. Like that. Alright, so we get the piece of paper and we come down a little bit. Down, down, down. Down, down, down. Oh, there we are. See? Just touching. So now, it's just touching. And the position, the machine position, is Z minus 447. Exactly. 447. So we go offset. The Z needs to be Z minus 447 dot input. 447. So the position is 447. Offset 447. You see that? That's how you do it. So we go Z home. Now another thing that can get you is, I'll show you in a sec. So that's my datum tool. That is set to the top of there, so we know that's 0. So it's my datum tool. So you go offsets. That is tool what? It's tool 4, right? So you got to go into your offset geometry page and go tool 4 is 0, right? There you go. See, it's 0. If it's not 0, it'll crash into the job or not be going down enough. So it needs to be 0 because it's the datum tool. And all the other tools that have values other than 0 are ones that are not datum tools. So we go program, start, and we just got to go single block check so we can see where it goes. So it's going to come down 6 more mil, and it's going to start feeding. So that's correct. Take off single block. Now maybe I'll just slow it down a little bit. Put the coolant on there. Well, let's just see it cut first. See, it's doing a counterbore here. Feeding alright, yeah. Should start cutting in a sec. There we go. See it cutting? So let's put the coolant on there. So we're going Z minus 1.5 to get rid of the case hardening for the tapping. So it does a canter bore every hole, 1.5 deep and a little bit bigger in the OD. Get rid of all the hardened surface because the crown wheel's case hardened, you see. And then the tap is only a high speed steel tap. So if you don't do this, the tap will fuck up literally straight away. Because if the tap's softer than the material, it ain't gonna cut. It's like trying to cut butter with it's like trying it's like trying to cut a piece of wood with a piece of paper. It ain't gonna work. So we can probably turn up that speed to 100. Once it finishes this one, I want to stop it and just show you, and then I can turn this video off because holding this phone is a bit difficult. So it's almost finished. Alright. So let's just turn the coolant off. Coolant off. Push this over there for a second. Let's just make sure it's doing the right thing. Put that away. Now look at this. See? Counterbore. Get rid of the hardened steel. Put the coolant back on. Start the program. And that's how it's done, you see. So, it's done all the counterbores. Get rid of the case hardening. Now it's sped up to, how many revs is that doing? 1800 revs. Doing 30 millimeters a minute. Doing the whole tapping size for a 12 mil by 1.25 pitch, 1 1/4 pitch. I hit the bottom then, and around it goes. Up it comes to go to the next hole. Boom, next hole. And it does that, and then it does the tapping. So now it's done all the holes. Now it's doing the tapping. Rigid tapping. So it's doing 250 millimeters a minute, and the spindle is 200. Each one of them values is a hole. So the next one will be X 39.676, Y minus 54.609. Rigid tapping. The last hole. And there we go. It's done. Okay. Okay, so I have But look at that. Just beautiful. Absolutely beautiful. So yeah, unclamp that, put it on a piece of Henry paper on a flat milling machine bed, rub it on the Henry paper like the Karate Kid does. Wax on, wax off, to get that burrs off there. And then you can bolt it to the carrier. The beautiful Quaife LSD.